morning. See, so today we discuss. So that is we start new chapter. So that is differentiation. Last class we have finished that vector chapter. And also I sent you already that important questions on vector chapter. Please solve that questions. So that is questions in 2015, 16, 17, 18, 19, 20. All questions we were already sent you. What questions they asked on vector chapter in the last class, right? So now today we discuss the new topic, that is differentiation. The weightage of this topic, there is 1 mark question, so 2 mark question, 2 3 mark question, 1 4 mark question, 1 5 mark question. That is continuity and differentiability is the topic name, but continuity I will explain later. We will start differentiation, right? So the weightage is 1 mark question, 2 mark question, 2 3 mark question, 1 4 and 5. So 3 5 8 11 15. So total weightage of this chapter is 20. So total weightage of this chapter is 20. See, so before going for differentiation, first we see, so that is standard formula. Everybody should remember this formula. Standard formula. So derivative of any function, first y, and its derivative is represented by dy by t. Derivative of any function, so that is y equal to f of x, its derivative is represented by dy by dx or f dash of x. We can represent in any form. So first, derivative of any constant. Derivative of any constant is 0. For example, derivative of 2, derivative of 3, derivative of 10, derivative of 100, derivative of 1000, derivative of -5. So derivative of any constant is 0. Derivative of any constant is 0. So derivative of x raised to n. Derivative of x raised to n is n into x raised to n minus 1. Derivative of x raised to n is derivative of x raised to n is n into x raised to n minus 1. For example, see, what is derivative of x cube? So this is the form of x raised to n, where n is equal to 3. Right? So that is n into, that is 3 into x raised to n minus 1. 3 minus 1 is 2. So that power we have to write here, and we have to power less than 1. So that is 3x square. Derivative of x raised to 5. What is derivative of x raised to n? N into x raised to n minus 1. So this power will come here, and you have to reduce this power by 1. So this power, that is 5, x raised to 5 minus 1, that is 4. Right? Similarly, derivative of x raised to 10, derivative of x raised to 10. See, this power will come here, x raised to 10 minus 1, that is 9. Similarly, derivative of x square. What is derivative of x square? Derivative of x square, this power will come here, that is 2x. X raised to 2 minus 1. What is 2 minus 1? 2 minus 1 is 1. So derivative of x power, if nothing is there, that is 1. N into, what is n value? N value is 1 into x raised to n minus 1, that is 1 minus 1 is 0. Anything raised to 0 is 1. So what is the answer? Answer is 1. Right? So derivative of x raised to n, that is n into x raised to n minus 1. This is how we can use x raised to n formula. Derivative of x cube. So 3 will come here. X raised to 3 minus 1. 3 minus 1 is 2. That power will reduce it by 1. So derivative of x raised to 5. That is 5. X raised to 5 minus 1 is 4. Derivative of x raised to 10. That is 10 x power 9. Derivative of x square. That is 2. X raised to 2 minus 1 is 1. So derivative of x. So derivative of x we are introducing. So derivative of x is 1. Similarly, derivative of 1 by x. We are repeatedly using this. Derivative of 1 by x is minus 1 by x square. How we are using this minus 1 by x square simply. We have to remember this formula. Derivative of 1 by x is minus 1 by x square. How we are getting minus 1 by x square simply. So that 1 by x, we can write it as x raised to what? Minus 1. Because this x power is 1. If it comes to numerator, that will become x raised to minus 1. So what is the derivative of x raised to n? That is n into x raised to n minus 1. So what is n here? N value is minus 1. X raised to n minus 1. What is n? Minus 1. This is the form of x raised to n. What is the derivative of x raised to n? N into x raised to n minus 1. So So that is minus 1 into x raised to minus 1 minus 1. That is minus 1 into x raised to minus 2. That we can write as minus 1 by x square. So derivative of 1 by x is minus 1 by x square. This also we are getting by using x raised to n formula. Right. Similarly, I will write derivative of 1 by x cube. See, don't mind, just remember that. So 1 by x cube is nothing but x raised to minus 3. Now this is the form of x raised to n. Right. So this is the form of x raised to n. So where n is equal to minus 3. Right. So what is the derivative of x raised to n? N into x raised to n minus 1. So what is n value here? Minus. N into x raised to n minus 1. What is n value? Minus 3. That is minus 3 into x raised to minus 3 minus 1 minus 4. Or this we can write as minus 3 divided by x power 4. Right. So derivative of 1 by x cube is minus 3 by x power 4. Right. So when it is 1 by x, 1 by x square, 1 by x cube, take it in the numerator, so that will become in the form of x raised to n. Then apply that formula, you will get the answer. So therefore, derivative of 1 by x cube or derivative of 1 by x power 5, that is nothing but x raised to minus 5. What is n value? N value is minus 5. Minus 5 into x raised to n minus 1. Minus 5 x raised to n minus 1. What is n? Minus 5 minus 1. Minus 5 into x raised to minus 8. So that is nothing but minus 5 divided by x raised to 2. Is it clear, friends? Right? So derivative of 1 by x raised to n, in general, that also we can write as 1 by x raised to n, that is nothing but minus n divided by x raised to n plus 1. We can observe this is the formula for 1 by x raised to n, that is minus n by x raised to n plus 1. Here we can observe what is n value? 3. Minus n, minus 3 by x power 4. What is n here? X raised to 5, that is minus 5 by x power 6. So derivative of 1 by x power 10, so that is minus 10 by x power 11. See here, what is the formula of derivative of 1 by x raised to n? Minus n by x raised to n plus 1. This numerator power n got right here, and you have to increase the denominator power by 1. So derivative of 1 by x raised to 7, that is minus, you have to write n here, that is x raised to 7 plus 1 is 8. Derivative of 1 by x cube, that is minus 3, you have to x raised to 3 plus 1, 4. Is there one? Right, so you have to remember the formula. So derivative of x raised to n is n into x raised to n minus 1. What is the derivative of 1 by x raised to n? Minus n divided by x raised to n plus 1. Is it clear? Right, so derivative of 1 by x raised to n. Similarly, derivative of root x. Derivative of root x is 1 by 2 root x. Right? So derivative of root x is 1 by 2 root x. Right? So derivative of any constant is 0. Derivative of x raised to n into x raised to n minus 1. Derivative of x is 1. Derivative of 1 by x minus 1 by x square. Derivative of 1 by x raised to n minus n by x raised to n plus 1. Derivative of root x 1 by 2 root x. Similarly, derivative of e raised to x. Derivative of e raised to x is e raised to x. Derivative of e raised to x, a into e raised to x. Right? So derivative of e raised to x. Derivative of e raised to x is e raised to x. Derivative of e raised to x, that is a into e raised to x. For example, see. Derivative of e raised to 3x, that is 3 into e raised to 3x. That power you have to write here. Then the derivative of e raised to minus 2x, that is minus 2 into derivative of e raised to minus 2x. Derivative of e raised to minus 5x, that is minus 5 into e raised to minus 5. So therefore, derivative of e raised to ax is a into derivative of e raised to x is a into e raised to x. Right? See. Then derivative of sin x. Derivative of sin x is cos x. You have to remember all this formula. Right? So derivative of cos x is minus sin x. Derivative of tan x is x square x. Right, so derivative of cosec x, that is minus cosec x into cot x. Similarly, derivative of sec x, that is sec x into tan x. Then derivative of cot x minus cosec square x. Derivative of sin inverse x, that is 1 by root of 1 minus x square. Derivative of cos inverse x minus 1 by root of 1 minus x square. derivative of tan inverse x, that is 1 by 1 plus x square. Then derivative of log x, 1 by x. Right, so derivative of log x is 1 by x. So then derivative of a raised to x. Derivative of a raised to x is a raised to x into log a. These are some standard formulae. We have some other formula also. Right, so derivative of any function. So I need its derivative, that is f of x. Its derivative is represented by f dash of x. When it is y, its derivative is represented by dy by dx. So derivative of any constant is 0. Derivative of x raised to n, that is n into x raised to n minus 1. Derivative of x is 1. Right? So derivative of 1 by x minus 1 by x square. So derivative of 1 by x raised to n minus n by x raised to n plus 1. Derivative of root x is 1 by 2 root x. Derivative of a raised to x log a. Right? So then derivative of e raised to x, that is e raised to x derivative is e raised to x itself. Then derivative of e raised to ax, that is a into e raised to ax. Right? So derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x sec square x. Derivative of cosec x minus cosec x into cot x. Derivative of sec x into tan x. Derivative of cot x minus cosec square x. Derivative of sin inverse x 1 by root of 1 minus x square. Derivative of cos inverse x minus 1 by root of 1 minus x square. Derivative of tan inverse x 1 by 1 plus x square. Derivative of log x 1. So still we have some more formulae, but these are the basic formulae that everybody should remember. So later we will start rules of differentiation, that is chain rule, product rule and quotient rule. So before going to that rules, before learning that rules, everybody should be very perfect in this formula. Right? So you have to read this formula, write it 2 or 3 times. So by the next class, you should be very perfect in all these formula. Right? Or you write this formula in 1 page and you can keep it for reference. So within few days, you must be very perfect in all these formula. Right? See here. Now we have some rules of differentiation. So before that rules, we will see some problems here. See students, you have to write all this formula and keep it for reference. When a given function is, so we have 3 rules for differentiation, that is chain rule, product rule and quotient rule. But see, when a given function is sum or difference of multiple functions, that is sum of f of x and g of x are 2 functions. Then how do we differentiate such function, that is dy by dx, that is f of x will become its derivative g of x, f dash of x, and we have to differentiate g of x also. When it is sum or difference of multiple function, then we have to differentiate each function independently. For example, y is equal to e raised to x plus sin x plus 2. Let us say this is a given function. It is sum of 3 functions, that is e raised to x, sin x and constant term. Then how to differentiate this? dy by dx. Already told you what is derivative of e raised to x? Derivative of e raised to x is e raised to x plus derivative of sin x. Derivative of sin x is derivative of sin x is cos x plus derivative of 2. 2 is a constant term. Already told you that 2 derivative of that constant is 0. Right? So that what is the answer is dy by dx is equal to e raised to x plus. Is it clear? So when a given function is sum or difference of multiple function, we have to differentiate each functions independently. Or see here. So y is equal to c cos x plus log x plus tan x. We can write cos x plus log x. It is also sum of or difference of 3 functions. C dy by dx. So what is derivative of cos x? Derivative of cos x is minus sin x plus derivative of log x. What is derivative of log x is 1 by x minus derivative of tan x. What is derivative of tan x? Derivative of tan x. Derivative of tan x is sec square. Right? So derivative of cos x minus sin x. Derivative of log x 1 by x minus as it is, right, as it is. Derivative of tan x is differentiate this function. So that is dy by dx. See, what is derivative of root x? Earlier I told you the formula. Derivative of root x is 1 by 2 root x minus, right, as it is. What is derivative of 1 by x? Derivative of 1 by x is minus 1 by x. Derivative of root x is 1 by 2 root x. Keep this minus as it is. What is derivative of 1 by x? Already I have given a formula. Derivative of 1 by x is minus 1 by x square. Derivative of e raised to 2x. Derivative of e raised to x is a into e raised to x. Derivative of e raised to 2x, that is 2 into e raised. Derivative of e raised to 2x is 2 into e raised to x. Therefore, dy by dx is equal to 1 by 2 root x minus into minus. Minus into minus is plus 1 divided by x square plus 2 into e raised to 2. So this is 35. Derivative of root x 1 by 2 root x minus keep as it is. Derivative of 1 by x minus 1 by x square. Derivative of e raised to 2x 2 into e raised to 2x. So when we have multiple functions, we have to differentiate each functions independently. Y is equal to 1 c sin inverse x plus, that is sin inverse x plus x power 4 minus 20 plus. So differentiate. When we differentiate, see dy by dx, derivative of sin inverse x 1 by root of 1 minus x square plus derivative of x power 4. What is derivative of x raised to n into x raised to n minus 1. What is n? N is 4 into x raised to n minus 1. 4 minus 1 is here n value is 4. What is derivative of x raised to n? That is n into x raised to n minus 1. So here n value is 4. 4 into x raised to 4 minus 1 is 3 minus derivative of 20. Derivative of 20 is 0. So therefore dy by dx is equal to 1 by root of 1 minus x square plus 4x. So this is how we can differentiate when a given function is sum or difference of multiple functions. Now see, so when given function is any constant into function f of x. Right, so when, what is the difference between these two? See, when it is some constant into f of x, when we differentiate, we have to keep that constant as it is, we have to differentiate this function. Right, but here, when we differentiate, so this constant term is an independent term here. So here derivative of a will become 0 and it is delta f of x. Here a into f of x is there, when it is product between a and f of x, this constant a we have to write as it is and derivative of f of x is f dash of x. Here derivative of a is 0 because this a is an independent term. So therefore again this derivative of f of x is f dash of x. For example, y is equal to 3 sin x and here y is equal to 3 plus sin x. What is the difference? So when we differentiate this function, that is dy by dx, 3 we have to write as it is because here it is a product. What is the relation between 3 and sin x? It is a product. So when it is a product, we have to write this 3 as it is. What is derivative of sin x? It is cos. But here dy by dx, see here, this derivative of 3 is an independent term here. 3 is an independent constant term. So derivative of 3 is 0 plus derivative of sin x is cos. Therefore answer is cos. When constant term is a product with any function, that constant term you have to write as it is. But when the constant term is an independent term, then derivative of that constant will become 0. See, y is equal to 2 sin, you can write 2 log x plus 4x plus 10. From differentiate, see, dy by dx is equal to 2, this constant, you have to write as it is because it is a product. Derivative of log x, this derivative of log x, 1 by x. Plus, 4 is a constant, you have to write as it is because it is a product. Derivative of x cube, derivative of x raised to n into x raised to n minus 1. Derivative 2 into derivative of x raised to n into x raised to n minus 1, 3x square plus derivative of 10 is 0 because this 10 is an independent term. So therefore dy by dx is equal to 2 by x plus 4 into 3, 12x square, and y is equal to 2 root x plus x cube, 2x cube plus 4x. Now differentiate dy by dx. This 2 is constant. What is derivative of root x? This 2 is constant and it is a product with root x. Keep 2 as it is. Derivative of root x 1 by 2 root x plus 2 is constant. Derivative of x cube. What is derivative of x cube? Derivative of x cube is 3x square plus 4 is constant. Derivative of x. What is derivative of x? Derivative of x. So 2 right hand is derivative of root x 1 by 2 root x. 2 right hand is derivative of x cube 3x square. 4 right hand is derivative of x is 1. So now here we will get answer. Now it is dy by dx. So that is 1 by root x plus 2 these are 6x square plus 4 into 1. See, about when a given function is sum or difference of multiple function, we have to differentiate each function independently. And again, when constant is a product with function, we have to keep that constant as it is and we have to differentiate the function. So here constant 4 as it is, derivative of x cube is 3x square. Here 10 is a constant independent term which derivative is 3. Here 2 is constant derivative of root x 1 by 2 root x. 2 is constant derivative of x cube 3x square. 4 is a constant derivative of x cube. So this is how we differentiate when the 3 functions or 4 functions, when it is sum or difference, we have to differentiate independently. And again, when the constant is multiplied by a function, we have to keep that constant as it is and we have to differentiate only the function. When constant is an independent term like 10 or 15, that derivative will become 0. Is it clear, right? So this is about some basics of differentiation and some basic formulae. So in the next class, we will go for rules of differentiation. So before going for rules, everybody should be very thorough or everybody should buy at this formula. If you know this formula, easily you can understand these rules. So first one is chain rule. So then product rule and quotient rule. We have 3 rules. So these 3 rules. So if you are very perfect in these 3 rules, 90% of differentiation chapter is over. First we will understand the chain rule, product rule and quotient rule. Next we will go for the problems in NCERT. Okay students, so go through all these formulas. So we by hand is all these formulas. In the next class, I will start with the chain. Is it clear students?